Hey everyone, welcome back to our channel. And today's video will know that what is mutability, the concept of mutability, and why it is dangerous in certain cases. Okay, so I think you all know that what is mutable data type and what is immutable data type. Okay, because mutable data type means that the value can be changed after it created, after the data type created. Okay, the value can be changed. Them like list, list and dictionary. And what is unmutable data type? The value cannot be changed after the creation. We said this data type unmutable data type. So what is mutability here? So mutability is a property or concept that defines whether an object's value can be changed after it is created. Means the behind the scenes is that the like list. When you create a list, we change the value of this list to keep the same memory location. In case of list, to keeping the same memory location, if you can change the value and delete the value, this is called mutability. Okay, the memory location and memory address is same, and you change the value and delete the value of this particular data type. This is called mutability. So here you can see over here that I took a list 1 2 3, and we also append 4 into the a list, and print the if I print a, we'll see that the append 4 is in this image 4 is inserted in the same memory location. Okay, but in case of unmutable data type, it will not happen. We'll in unmutable data type we see over here that import copy and b is equal to a. I assign the a in the b variable. If I update the b variable, we cannot share the, you see the image, there is created different memory location and different memory created different memory address. A point to the reference to the different memory, a point to the one memory location and b point to the different memory location. It's not like a list. Okay, like here we can see that in case of, we saw that in case of tuple the memory location is different, but in case of list the memory location are same. A and b point to the same memory location. When you print a, the print also a also be updated, will be updated, a also changed too. Okay, this is called mutability. The memory location is the same. Okay, so why mutability is dangerous? Mutability is dangerous. Like here in this case, we'll see over here, a, you create a list a and you assign the a list in the b, and when you update the b list, automatically it will update the a list also. So in case in your program you can use this way, and you don't know that why and how the a also be changed. It will show you throw error. That's why it is dangerous. Like over here, this function df add item, if the here you can see that the my list and the before function after function, the my list value is changed. We can't change the my list. I just use the function to append, and you append item, but it change the my list. This is the dangerous thing. Okay, when you program, you use a lots of function, when and what variable changed in particular function cannot find out, it will throw any error. Okay, in other function when you use this list, if you keep this global variable, it will change. Global variable, define a list in global variable, the list can be changed with the help of one function. That's dangerous. Okay, also you can see some coding also, and how we can see that. I'll just print it id. If I print the id, you see over here it will take time. The memory location is same. Okay, after append and before append memory location are same. We'll see already saw in this PPT. In case of immutable array, the memory location are different. Okay, this is how it is dangerous. Also, you see AI function here, run it. You see that how it change. This is how it change. So the solution of it, how you can avoid this. Okay. For that, you have to use copy method. The two particular copy method you can use. One is shallow copy, another one is deep copy. A shallow copy creates a new object but doesn't recursively copy nested object. Means in case of nested object, nested list, it will not work. Nested list can be changed. Like over the see, I create a copy, input copy and copy.copy original, and we modify the list. We'll see the original and shallow defined. Original list is not changed, it's the same because we use copy method. And in case of nested list, the value can be changed. We'll see 30 and 30. For nested list, it will not work. Shallow copy not work. We'll see how it work over here. Yeah, shallow copy. In case of shallow copy, you see that shallow copy. In case of shallow copy, you see that it find no here not yeah, problem with shallow copy. Copy and append B in the nested list. This how it will work. They share the nested list object in the same memory location. A and B focus on different memory location, but in case of nested list, it will share the same memory location and same memory ID. That's why the value changed like this. If you saw in the image. Okay. So what is the solution for this? For that, we have a different copy method, deep copy. You can use deep copy. Deep copy creates a completely independent copy of the object, including all nested element. You'll see over that A and B create a different memory location and store in the different memory. And the nested list, in case of nested list, also store in different memory location. Okay, you can use deep copy for nested list. Deep copy also very important. We'll show deep copy. If you print this, you'll see the result. It won't change. Okay, we'll print also print. You see, if you use copy in item, in function, before function 1 2 3, after function 1 2 3, result changed. We change the function append in real variable changed, but before function after function mileage it's not changed. Okay, that's why we use copy method. This is very important. We never saw that why the value is changed. You cannot understand if your program, your coding is so long. Okay, it will throw an error. You cannot see how is the value changed. Say if you like this particular video, please give a thumbs up and subscribe to my channel. Thank you guys.